Welcome back to Strange Epochs. I'm Sean Spainhour, and this is the show where we take one strange, true, documented moment from somewhere in the long and bewildering span of human history, and we sit with it. This week we are going to Siberia, June 30th, 1908, 7:17 in the morning. Something is coming. It has been traveling for millions of years, or billions, through the cold and silence of space, on an orbit that has never intersected with anything significant until now. It is moving at approximately 60,000 miles per hour. It is roughly the size of a 10-story building, and it is about to do something to the atmosphere above central Siberia that nothing in human experience has a framework for. In a few seconds, it will detonate. The explosion will be somewhere between 3 and 50 megatons of TNT and equivalent. The estimates vary widely because no instruments were close enough to measure it precisely. For comparison, the atomic bomb dropped on Hiroshima was approximately 15 kilotons. The Tunguska explosion was at minimum 200 times larger. At the upper end of the estimates, it was over 3,000 times larger. The most powerful nuclear weapon ever detonated by human beings was the Tsar Bomba, a Soviet hydrogen bomb tested in 1961 at 50 megatons. Tunguska may have matched it. 80 million trees will be flattened across 2,000 square kilometers of Siberian forest. The shockwave will travel around the world twice, recorded on barometric instruments as far away as England. The ground vibrations will register on seismographs across Europe. For several nights afterward, the skies over Europe will glow so brightly that people in London can read newspapers at midnight without artificial light. And the thing that caused all of this will leave no crater, no wreckage, no fragments large enough to hold in your hand. It will be gone, utterly vaporized, leaving behind only the flattened forest and the testimonies of the people who felt the ground move beneath their feet and looked up to see the sky on fire. The Tunguska event happened. It is not in dispute. What it was, exactly, and what it means for the planet we live on is a question we have been working on for over a century. New episodes every Tuesday at 5 in the morning. Sources are always in the episode description. Let's begin. Banavara Trading Post, Central Siberia, June 30th, 1908. A little after 7 in the morning, a man named Semenov is sitting on the porch of his house. It is early summer in Siberia. The light is already full and clear at this hour. The sky above the taiga a deep, clean blue. Semenov is facing north, watching nothing in particular. He is a settler at the trading post, about 65 kilometers south of where the thing will happen, far enough to survive, close enough that what he is about to experience will stay with him for the rest of his life. He sees it first as a split in the sky. That is how he describes it 22 years later to the Russian scientist Leonid Kulik, who has finally made it out to the Tunguska region to collect testimony about what happened. The sky split in two, Semenov says, and fire appeared high and wide over the forest to the north. The split grew larger. The entire northern side of the sky was covered with fire. And then the heat hit him. He says it felt as if his shirt was on fire. He says the heat came from the north, from where the fire was, and it was so intense that he could not bear it. He jumped up from his porch and ran. Then the blast wave arrived. Semenov was thrown from his feet. He was knocked unconscious. When he came back to himself, he was on the ground some distance from where he had been standing. The porch where he had been sitting had had its door frames blown out. The ground had trembled beneath him like the earth was shaking itself apart. There was a sound like a cannon, not one shot, but many, one after another, rolling thunder that lasted for what seemed like minutes. He was 65 kilometers away. Closer in the forests and on the river, the Evenki people, the indigenous reindeer herders of the region, had their own experiences of the event. Some described being thrown from their feet and their tents destroyed. Some described a heat so intense it felt like the sky was burning. One man said the ground moved under him like a wave. One described something that the Evenki called a fire column that rose from the earth to the sky and then spread out. Hundreds of reindeer were killed. The Evenki called the place of the explosion Ogdi, the name of their god of thunder, and for years afterward they would not go near it. The Evenki reindeer herder Akulina and her partner Ivan were in their tent near the Chambe River that morning, roughly 40 kilometers from the epicenter. In their account, recorded by investigators years later, they described the light coming into their tent, then the sound, then both of them being thrown across the interior of the tent as if by an invisible hand. When they emerged, trees around them had been flattened. The ground was hot. Everything was silent in a way that the taiga, normally alive with birds and insects, was not supposed to be. The silence after the blast lasted for minutes, as if every living thing in the forest had been stunned into stillness by what had just happened. An Evenki elder named Vasily Ilyich Chuchancha described the event this way. The sky was split in two above the forest. Then fire appeared, high and wide. The fire was so bright that it set the whole sky on fire. Then there was a great rumbling sound, and the ground shook. Then the wind came and knocked him off his feet. When he stood up, the trees were falling. 250 kilometers away, a man at Kamsk railway station reported that his train trembled as if from an earthquake, and he was afraid the carriages would leave the rails. 500 kilometers away, observers described a fireball visible in the cloudless daytime sky. 1,000 kilometers away, seismographs registered the tremors. In England, more than 6,000 kilometers away, barometric instruments recorded the shockwave passing twice, once as it traveled east and once as it circled the globe and returned from the west. The blast wave circled the planet twice. Act 1, June 30, 1908 Inhale. The Tunguska Event happened in one of the most remote and inaccessible regions on Earth. To understand what that remoteness means, it helps to have a picture of what the Siberian taiga actually is. The taiga, from a Turkic word meaning marshy forest, is the largest biome on Earth. It stretches across the northern latitudes of Russia, Canada, and Scandinavia in an almost unbroken belt of conifer forest, covering approximately 17 million square kilometers. The Russian portion alone is larger than the continental United States. Within it, the Podkamennaya Tunguska River flows for 1,000 miles through a landscape of spruce and pine and larch, through wetlands and river valleys and low hills, in a region so remote that it had no roads, no railways, no telegraph lines, and no permanent settlements of any significant size in 1908. The people who lived in this landscape were the Evenki, a semi-nomadic people who had inhabited the central Siberian taiga for thousands of years. They were reindeer herders and hunters, moving seasonally through the forest, their lives organized around the movements of the animals and the rhythms of the short Siberian summer and the long, brutal winter. They knew the taiga with an intimacy that no outside observer could approach. They had names for every river and every hill and every kind of wetland. They had accumulated, over generations, a knowledge of this landscape that was as sophisticated and detailed as any scientific survey, though organized according to entirely different principles. This remoteness is the reason we know as little as we do about the Tunguska Event. It is the reason the first scientific expedition did not reach the site until 1927, 19 years after the explosion. And it is the reason that the event, which was by any measure the most powerful explosion in recorded human history, was barely noticed by the wider world when it happened. The Tsar's government received reports. Some regional newspapers ran brief items. The scientific community was aware that something had happened. And then, for almost 2 decades, almost nothing. Russia had a revolution to have, a world war to fight, a civil war to survive. The remote taiga would wait. But on the morning it happened, June 30th, 1908, the event was experienced across an enormous area of Siberia with an immediacy and violence that the people living through it had no framework for. It is worth pausing on that last phrase. No framework. The people in the path of the Tunguska event had access to a rich and long-standing body of knowledge about their environment, but nothing in that knowledge, nothing in the experience of the Evenki people over thousands of years in the taiga, nothing in the European scientific tradition, nothing in the accumulated experience of any human civilization on Earth had prepared anyone for a rock the size of a building arriving from space at 60,000 miles an hour and exploding with the force of a nuclear weapon. The closest analogs available to people in 1908 were earthquakes, which they knew, thunderstorms, which they knew, volcanoes, which most of them did not know from personal experience but had heard of. None of these came close to describing what had actually happened. The Evenki response, to name it after their god of thunder, to avoid the place, to fold it into a sacred geography of dangerous and powerful locations was, given the available framework, a completely rational response. The Russian settlers' response, to describe it in terms of earthquakes and artillery in the sky catching fire, was equally rational given their available framework. The scientists who read those accounts and concluded that a giant meteorite had fallen were doing the best they could with what 19th century geology and astronomy had given them. Everyone was working with their best available tools, and nobody's tools were quite adequate to the thing that had happened. Let's try to reconstruct what actually happened as best we understand it. At approximately 7:17 in the morning, local time, an object entered the Earth's atmosphere from the southeast. It was traveling at somewhere around 27 kilometers per second, about 60,000 miles per hour, and it was moving at a relatively shallow angle to the surface, somewhere around 30 degrees. This angle of entry matters. A steeper angle would have brought the object to the surface faster, potentially leaving a crater. The shallow angle meant it spent more time moving through the increasingly dense atmosphere, accumulating heat and pressure on its leading surface until the structural stress exceeded what it could withstand. What the object was, exactly, is still debated. The current scientific consensus favors a stony asteroid, a rocky body of roughly 50 to 60 meters in diameter, not metallic, which is why it left so little recoverable material. A metallic asteroid of the same size would likely have penetrated deeper into the atmosphere and possibly reached the surface, leaving a crater. A stony body of this size tends to shatter and vaporize in the atmosphere, releasing its energy in a massive airburst, exactly what the evidence suggests happened at Tunguska. For decades, a competing theory held that the object was a comet, a body of ice and rock rather than solid stone, which would explain the almost total absence of recoverable fragments even more neatly, since a comet would leave even less solid material than a stony asteroid. The comet hypothesis had a certain appeal and was supported by several prominent scientists through much of the 20th century. The current balance of evidence favors the asteroid explanation, but the comet theory has not been entirely ruled out. The object vaporized so completely that the physical evidence required to settle the question definitively may simply not exist. Whatever it was, it exploded at an altitude of approximately 5 to 10 kilometers above the Siberian taiga. 5 to 10 kilometers is low enough that the full force of the explosion was directed at the surface below. It is the difference between a detonation in the upper atmosphere, where the energy dissipates across a vast area with relatively minor surface effects, and a detonation close enough to the ground that the pressure wave and the thermal pulse arrive at the surface with devastating intensity. Tunguska was close close enough that the trees for dozens of kilometers in every direction were flattened, close enough that a man 65 kilometers away felt his clothing begin to burn, close enough that the pressure wave was still strong enough to knock people off their feet when it arrived, traveling at the speed of sound minutes after the light. The explosion released an amount of energy that has been estimated by different methods and different researchers at anywhere from 3 megatons to 50 megatons, TNT equivalent. The most commonly cited figure is somewhere around 10 to 15 megatons, roughly 1,000 times the energy of the Hiroshima bomb. The effects were sequential and almost cinematic in their scale. First, the light. Witnesses at various distances described a column of bluish light, brighter than the sun, moving across the sky. Some described a fireball with a trail. Some described the object as appearing to change course. Those scientists who have studied the eyewitness reports are skeptical of this and attribute the apparent course changes to the observer's own movement and the dramatic visual effects of something that bright moving across the sky at that speed. At distances of 200 kilometers and more, witnesses described a brilliant object easily visible in the cloudless daytime sky, leaving a trail of smoke or fire behind it. Then, the flash. The explosion itself was brilliant enough to be seen from hundreds of kilometers away. Witnesses described the northern horizon lighting up. Witnesses closer in described something that blotted out their field of vision entirely, a white light that left them temporarily unable to see. Then, the heat. The thermal pulse from an explosion of this magnitude, even at 5 to 10 kilometers altitude, was sufficient to cause burns. Semenov, 65 kilometers away, felt his shirt was on fire. Evenki herders closer to the epicenter were knocked down by heat that felt like an open furnace. Trees within the immediate blast zone were scorched. The radiant energy from the explosion was enough to set fire to the forest across a significant area, but then the blast wave arrived and extinguished many of those fires before they could spread. Then, the blast wave. The pressure wave from the explosion traveled outward at the speed of sound, and when it arrived at Vanavara 65 kilometers away, traveling for approximately 3 minutes after the explosion, it was still powerful enough to throw people off their feet and blow out window frames. Trees within 40 kilometers of the epicenter were flattened. Trees within a smaller radius near the epicenter were left standing, but stripped of their branches and bark, transformed into what investigators would later call telegraph pole trees, bare trunks pointing at the sky, their every branch and twig blasted away by the overpressure of the blast wave. In the immediate zone, the devastation was total. At intermediate distances between 60 and 200 kilometers from the epicenter, the experience was somewhere between Semenov's ordeal and the merely dramatic. A trader at the Kejma station, about 200 kilometers away, reported that the sky in the north suddenly flashed and reddened. Then there was a tremendous crack and a sharp crack, as if the sky were cracking open. He was knocked from his chair. At Kirinsk, about 400 kilometers out, the sound arrived as a series of 4 or 5 bangs, like distant cannon fire, and the ground trembled. Every account describes the same sequence. First, the light, impossibly bright and silent. Then, after a delay that varied with distance, the physical shock, the ground shaking, the air pressure changing, buildings trembling. And then, after another delay, the sound. The delays between light and shock and sound were not accidents. They were the physics of the event, written in human testimony. Light travels at 300,000 kilometers per second and arrives essentially instantly. The blast wave travels at the speed of sound, roughly 1 kilometer per second, and takes 65 seconds to reach someone 65 kilometers away. The ground tremor, traveling through the earth at seismic velocities, arrives on its own schedule. Each witness experienced the same event at the speed appropriate to their distance, the same catastrophe arriving in layers, each layer governed by a different physical law. Then, the sound. At distances of 500 kilometers, the explosion sounded like artillery fire. At 1,000 kilometers, it was audible as a deep rumbling. The sound arrived long after the light and the heat and the blast wave because sound travels so much slower than the initial explosion effects. For witnesses at distance, the event unfolded in phases. First, the silent fire in the sky, then the trembling of the ground, then, minutes later, the sound. Act 2. Kulik and the Investigation. For 19 years, the Tunguska Event sat in the files of the Russian scientific establishment, noted but uninvestigated. The region was too remote. The country had too many other crises. And in the absence of any obvious catastrophe, no city had been destroyed, no people had died in significant numbers. The damage was to trees in a forest that nobody lived in. There was no urgency. Then, in 1921, a Russian mineralogist named Leonid Kulik began surveying Siberia on behalf of the newly formed Soviet Academy of Sciences, cataloging meteorite falls and collecting accounts of unusual events. He came across the scattered accounts of the 1908 explosion and became convinced that something extraordinary had happened, something that warranted scientific investigation. He spent years building the case for an expedition, collecting eyewitness accounts from traders and indigenous people, poring over newspaper archives, piecing together a picture of an event that had been almost entirely ignored by the scientific establishment. The journey to the Tunguska region in the 1920s required traveling by train across the Trans-Siberian Railway to the city of Kansk, then by horse-drawn sled across hundreds of kilometers of taiga in winter, then by boat up the river systems when the ice broke in spring. It took months. It required the cooperation of local guides, mostly Evenki and Russian settlers, who had their own memories and fears about the explosion site. When Kulik finally described glimpsing the blast zone for the first time in 1927, he wrote that he could not sort out his chaotic impressions. The scale of the destruction was beyond anything he had pictured from the eyewitness accounts he had collected over the previous 6 years. In 1927, he finally made it to the site. What Kulik found, nearly 2 decades after the explosion, was staggering. The scale of the destruction was beyond anything he had been prepared for. The flattened forest extended for dozens of kilometers in every direction from the epicenter. Trees had been knocked down and left lying radially outward from the center, like the spokes of an enormous wheel. At the epicenter, the telegraph pole trees stood stripped and bare in a field of devastated ground. The total area of fallen trees was eventually surveyed at approximately 2,100 square kilometers, an area larger than London. Estimates settled on approximately 80 million trees felled, and there was no crater. Kulik had expected a crater. The entire premise of his expedition was that a giant meteorite had hit the Tunguska region, and a meteorite impact of sufficient energy to flatten 2,000 square kilometers of forest should leave a very large crater indeed. He had imagined something comparable to the Behringer crater in Arizona, which is over a kilometer across and was formed by a much smaller impactor than whatever had hit Tunguska. He expected to find a hole in the ground. There was no hole. There was a marshy bog at the epicenter, which Kulik initially thought might be a water-filled crater, but subsequent investigation showed it was simply a pre-existing wetland. There was no crater anywhere in the blast zone. There was no large meteorite fragment. There was no obvious physical remnant of the thing that had caused all this devastation, nothing that could be picked up and examined and identified. Just the fallen trees, spreading outward for miles, and the standing stripped trunks at the center, and the silence of the taiga. Kulik's written account of his first visit to the epicenter has a quality that is difficult to categorize. Part scientific report, part elegy. He describes standing in the center of the devastation and trying to absorb what he was seeing. The telegraph pole trees around him, stripped bare and standing like sentinels. The flattened forest extending in every direction as far as he could see, the fallen trunks all pointing away from where he stood, the silence, the absence of a crater where logic told him there should be one. He had spent years imagining this place, collecting accounts of it, building arguments for the funding to reach it, and now he was here, in a landscape that confirmed the scale of what had happened and refused to provide the explanation he had come for. Kulik returned to the site multiple times over the following decade, convinced that the meteorite fragments must be there somewhere, buried in the bog. He led excavations. He drained wetlands. He found nothing. The thing had vaporized. Whatever it had been, it had given everything it had to the atmosphere and left nothing of itself behind that was recoverable by the instruments and methods of the 1920s and 30s. This absence, the absence of a crater, the absence of fragments, the absence of any physical remnant of the thing itself, became the central mystery of the Tunguska Event and the engine that drove a century of speculation. Later expeditions, equipped with better tools, did eventually find trace evidence of the object's composition. Microscopic spheres of silicate and magnetite were recovered from soil samples and from resin within preserved trees near the blast site. These microparticles had a chemical signature consistent with extraterrestrial material, a nickel to iron ratio characteristic of meteorites rather than terrestrial rock. They were extraordinarily small, but they were there, embedded in the landscape, the residue of a body that had given its substance to the atmosphere in an instant of unimaginable energy release. The microparticles confirmed the extraterrestrial origin of the event. They did not resolve the question of exactly what kind of extraterrestrial object it had been. The absence of a crater and the absence of fragments did something interesting to the public imagination. It left a gap in the explanatory framework, and gaps in explanatory frameworks tend to attract theories. If there was no crater and no meteorite, then what was there? The answer, a stony asteroid that vaporized completely in an airburst, is correct but unsatisfying in a particular way. It feels incomplete. It lacks a physical artifact. It requires believing that something with the energy of 1,000 nuclear bombs came and went without leaving anything you could hold in your hand. Human minds, which evolved to understand cause and effect at the scale of the immediately perceptible, sometimes struggle with that kind of total annihilation. There should be something left, and when there isn't, the mind reaches for other explanations. In the 1950s, a Russian science fiction writer named Alexander Kazantsev published a story in which he proposed that the Tunguska explosion had been caused by an alien spacecraft with a nuclear engine that had exploded in orbit. The story was fiction, but it was taken seriously in certain circles, partly because of the genuine similarities between the Tunguska event and the nuclear weapons testing that followed World War II. Both produced airbursts rather than ground impacts. Both scorched forests without starting sustained fires. Both left standing, stripped tree trunks near the epicenter. The comparisons were real. The nuclear alien ship hypothesis was not. But for a period in the 50s and 60s, it circulated in Soviet popular culture with a persistence that embarrassed some scientists and delighted others. There were other theories. A miniature black hole passing through the Earth, which was argued to require a corresponding entry wound somewhere in the North Atlantic, and no such wound has been found. A chunk of antimatter annihilating upon contact with the atmosphere. A Tesla weapon, a Nikola Tesla death ray, tested from his laboratory in New York, accidentally or intentionally aimed at the Siberian wilderness. This last theory is particularly durable in certain corners of the internet. Despite having no supporting evidence whatsoever and requiring Tesla to have developed technology that has never been replicated by anyone since, including people who have had a century to try. Professional scientists, largely uninterested in antimatter and alien ships and Tesla death rays, continued the quieter and more productive work of studying what the physical evidence actually said. By the late 20th century, the airburst hypothesis, the idea that a stony asteroid had entered the atmosphere and exploded before reaching the surface, had become the dominant scientific consensus and it has remained so. The asteroid explanation accounts for all of the observed evidence: the airburst, the absence of a crater, the radial pattern of tree fall, the thermal pulse, the tiny microparticle residue. It requires no alien ships, no antimatter, no death rays. It requires only a rock, traveling fast, meeting an atmosphere. Act 3. What Tunguska means. The Tunguska event was the largest impact event in recorded human history. It was also, in terms of its human consequences, remarkably minor. The region was so sparsely populated that casualties were minimal, possibly zero confirmed human deaths, though two accounts exist of people who may have been killed by the blast. The reindeer herds of the Evenki suffered badly, with hundreds of animals killed, but no city was hit, no significant human community was in the path of the destruction. The forest took the blow, and the forest, over the following decades, grew back. This is the central fact that makes Tunguska so disturbing when you think about it carefully. It happened in the wrong place. If the Tunguska object had entered the atmosphere 4 hours and 47 minutes later, the time it would have taken for the Earth's rotation to bring the next major population center into alignment with that trajectory, it would have exploded over St. Petersburg, then the capital of the Russian Empire. If it had arrived with slightly different timing, it might have hit London, or Berlin, or any of the major cities of early 20th century Europe. The Royal Observatory at Greenwich, which photographed the bright glow in the sky over London in the nights following the Tunguska event, not knowing what it was, would have been within the blast radius. To make this concrete, the City of London covers approximately 1,500 square kilometers. The Tunguska blast zone covered approximately 2,100 square kilometers. If the Tunguska object had entered the atmosphere on the same trajectory but arrived when the Earth's rotation had brought London into the path, the entire city, everything within the M25, everything that London was and contained in 1908, would have been inside the radius of total destruction. The Houses of Parliament, Buckingham Palace, the British Museum, St. Paul's Cathedral, all of it flattened and scorched in a fraction of a second by an object that the people inside would never have had warning of. The Tunguska event happened in 1908, 3 years after the first sustained powered airplane flight, and 7 years before the First World War. The 20th century was already accelerating toward its catastrophes, and something with the energy of 1,000 Hiroshima bombs arrived at the planet and detonated harmlessly over a forest. The margin by which that happened harmlessly is the margin of the Earth's surface that is empty, and the Earth's surface is proportionally largely empty. The chance of a random impact hitting a major city is small, but it is not zero, and Tunguska shows us what the consequences are when the number comes up. The event was the largest impact in recorded human history, but it was not large by geological standards. Astronomers believe that Tunguska-scale events, objects of this size impacting or exploding in the atmosphere, occur somewhere on Earth approximately once per century on average. Most of those events happen over ocean, or over uninhabited land, or go unrecorded entirely. The one in 1908 happened to occur over inhabited, if sparsely populated, land and was witnessed. But the geological record contains evidence of much larger impacts that dwarf Tunguska by orders of magnitude. The extinction level impact 66 million years ago that ended the Cretaceous period was carried by an object approximately 10 kilometers across, roughly 200 times the diameter of the Tunguska object, and, in terms of energy release, roughly 1 billion times larger. The universe does not have a preference for empty ocean. The Tunguska event has become, in the century since it happened, the central reference point for the science and policy of planetary defense. The field dedicated to identifying near-Earth objects that could pose a threat to civilization and developing the means to deflect or destroy them. The United Nations proclaimed June 30th the anniversary of the Tunguska Event, as International Asteroid Day. Specifically to raise public awareness of the threat, NASA established its Planetary Defense Coordination Office. In 2022, NASA's DART mission successfully redirected a small asteroid by deliberately crashing a spacecraft into it. The first real-world test of asteroid deflection technology, conducted in explicit response to the kind of threat that Tunguska demonstrated was real and not merely theoretical. All of this planetary defense infrastructure, the telescope networks, the tracking systems, the deflection research, the international agreements traces back in a direct line to a Tuesday morning in June 1908 when something exploded over the taiga and a man named Semenov felt his shirt catch fire 65 kilometers away. But I want to stay with the Evenki for a moment before we close, because their experience of the event is the one that is easiest to overlook and perhaps the most worth remembering. The Evenki people had been living in the Tunguska region for centuries. They knew the taiga in ways that no outside observer could match its seasons, its animals, its rivers and wetlands, its moods and dangers. And on the morning of June 30th, 1908, something happened in their world that had no precedent in anything their culture had ever experienced or recorded. The sky caught fire, the earth shook, the trees fell, the reindeer died. The world for a moment became something that the world was not supposed to be. They called it Ogdi, the god of thunder. They stayed away from the epicenter for years. When Russian scientists finally began arriving to investigate the explosion, the Evenki who guided them through the taiga did so with a wariness and a reluctance that the scientists interpreted as superstition, but that was, in fact, the reasonable response of people who had been present when something genuinely terrifying had happened in a place they loved and depended on. The scientists wanted to know what it was. The Evenki already knew something perhaps more important, that it had happened, and that the world in which it had happened was not the safe, predictable world that daily life encouraged them to believe in. They had felt the heat and been thrown from their feet and watched their reindeer die, and they had named it and stayed away from it and folded it into their understanding of a world that sometimes does things without warning. That understanding that the world sometimes does things without warning is something that the science of planetary defense has been trying to formalize and respond to for the last several decades. The Evenki knew it in their bodies in 1908. There is a final thing about the Tunguska event that I keep coming back to. In 1908, no one connected the bright glowing skies over London and Berlin and Moscow to the explosion in Siberia, because no one outside of the Siberian hinterland knew the explosion had happened. Information moved slowly. Russia was vast. The taiga was inaccessible. The people who had been closest to the event, the Evenki, the Russian settlers at Vanavara, had no mechanism to communicate what they had experienced to the wider world in any timely way. The thing happened. People felt it, people survived it, and the world went on, mostly unaware, for years. That would not happen today. The seismographs, the barometric instruments, the infrasound networks, the satellite surveillance systems that modern governments operate, all of them would detect a Tunguska-scale event within minutes. The information would propagate globally within hours. Scientists would know what had happened and approximately where before the dust had settled. The response, if there was anything meaningful to respond to, would be organized within days. What would not change is the physics. The rock would still arrive at 60,000 miles an hour. The explosion would still release the energy of 1,000 nuclear weapons. The trees would still fall. The ground would still shake. The sky would still split. The universe's capacity for this kind of event is unchanged by our improved ability to observe and discuss it afterward. We still don't know exactly what the Tunguska object was. Stony asteroid, almost certainly. Rocky, probably. Somewhere between 50 and 80 meters across. Traveling at approximately 60,000 miles per hour, entering the atmosphere at a shallow angle, exploding at an altitude of 5 to 10 kilometers in an airburst that released energy equivalent to somewhere between 1,000 and 3,000 Hiroshima bombs, leaving behind no crater, no fragments, almost nothing recoverable, just the flattened trees, the stripped trunks, the microparticles in the soil, and the testimonies of the people who were there. And the knowledge, the specific data-verified, seismograph-confirmed, barometric, instrument-recorded knowledge that the universe has no obligation to miss. That's what Strange Epochs is. Stories that have no clean endings. Moments that history recorded but never quite explained. Events that happened, undeniably happened, and yet still somehow feel impossible. Everything you heard in this episode is real. Every name, every date, every detail drawn from documented historical sources. All of the sources for this episode are listed in the episode description below. I encourage you to look them up. If you enjoyed this episode, please follow Strange Epochs wherever you listen. New episodes drop every Tuesday. And if you want to help the show grow, leaving a review goes a long way. It really does. I'll see you next week. I'm Sean Spainhour. This is Strange Epochs.